Ever wondered why your JavaScript code sometimes behaves like it has a mind of its own? You call a function before it's even defined, or a variable suddenly becomes undefined out of nowhere. Welcome to the world of scope and hoisting. In this video, we will cover JavaScript scope and hoisting practice questions, master JS fundamentals. Master the core concepts of JavaScript with these 30 practice questions focusing on scope and hoisting. In today's video, we are diving deep into JavaScript scope and hoisting with 30 comprehensive, exam-style practice questions. Whether you're preparing for a certification or a high-stakes technical interview, these questions will test your knowledge of lexical scope, the temporal dead zone, and the nuances of var, let, and const. Make sure to grab a pen and paper to track your score, and let's see if you can get all 30 right. What will be the output of console.log? A. var equals 10. Option A, reference error. Option B, undefined. Option C, 10. Option D, null. The correct answer is B. Variables declared with var are hoisted to the top of their scope and initialized with undefined. Therefore, when the log statement executes before the assignment, it sees the declared variable, a, but its value hasn't been set yet, resulting in undefined. This is a classic example of how var hoisting works, where only the declaration is moved to the top, not the initialization. What happens when you run console.log? B. Let b equals 20. Option A, undefined. Option B, 20. Option C, reference error. Option D, type error. The correct answer is C. Unlike var, variables declared with let and const are hoisted but not initialized. They enter a state called the temporal dead zone, TDZ, from the start of the block until the declaration is reached. Attempting to access them during this time results in a reference error. This behavior was introduced in ES6 to encourage better coding practices and reduce bugs related to variable usage before declaration. Which of the following is fully hoisted in JavaScript? Option A, function declarations. Option B, function expressions. Option C, arrow functions. Option D, class expressions. The correct answer is A. Function declarations. E.g., function myfunc, opening curly bracket, closing curly bracket, are fully hoisted, meaning both the function name and its body are moved to the top of the scope. This allows you to call a function before it is written in the source code. On the other hand, function expressions and arrow functions are treated like variables. They are subject to the hoisting rules of var, let, or const depending on how they are declared. Where is a variable declared with const accessible? Option A, everywhere in the script. Option B, only within the function it is defined in. Option C, only within the block, curly braces, it is defined in. Option D, only within the module. The correct answer is C. The const keyword, along with let, provides block scope in JavaScript. This means the variable is only accessible within the nearest set of curly braces, where it was defined. This includes if statements, for loops, and functions. This is more restrictive and safer than var, which is function scoped and can leak out of blocks like if or for. If a variable is declared outside of any function or block, it belongs to the Option A, local scope. Option B, functional scope. Option C, global scope. Option D, module scope. The correct answer is C. Variables defined outside of any function or block level statement are considered to be in the global scope. In a web browser environment, these variables become properties of the window object. They are accessible from any other part of the code, which can be useful but also risky if multiple scripts use the same global variable names. Global namespace pollution. What is it called when a variable in an inner scope has the same name as a variable in an outer scope? Option A, hoisting. Option B, shadowing. Option C, cloning. Option D, overriding. The correct answer is B. Variable shadowing occurs when a variable declared within a specific scope, like a function or block, has the same name as a variable in an outer scope. The inner variable shadows or hides the outer one within that scope. When the engine looks for that variable name, it finds the inner one first and stops searching, effectively making the outer variable inaccessible inside that specific inner scope. What is the result of greet? Var greet equals function console.log hi. Option A, undefined. Option B, reference error. Option C, type error. Greet is not a function. Option D, logs hi. The correct answer is C. In this case, greet is declared using var, so it is hoisted and initialized as undefined. When greet is called, the JavaScript engine sees greet exists but its value is undefined. Since undefined is not a function, calling it results in a type error. This highlights the key difference between function declarations, which would work, and function expressions assigned to variables. How does the JavaScript engine resolve a variable name? Option A, it only looks in the global scope. Option B, it looks in the current scope, then outer scopes until the global scope. Option C, it looks only in the function where it's called. Option D, it uses a random search algorithm. The correct answer is B. This process is known as searching the scope chain. When a variable is used, the engine first looks in the immediate local scope. If not found, it moves up to the parent scope, continuing this process until it either finds the variable or reaches the global scope. If the variable is still not found in the global scope, a reference error is thrown. This bottom-up search is fundamental to how lexical scoping works in JavaScript. If a variable and a function share the same name in the same scope, which declaration takes precedence during hoisting? Option A, the variable declaration. Option B, the function declaration. Option C, neither. It throws an error. Option D, the one defined last. The correct answer is B. Function declarations are hoisted before variable declarations. If there is a function declaration and a var declaration with the same name, the function wins the hoisting battle and the identifier will initially point to the function. However, if the variable is subsequently assigned a value during execution, it will overwrite the function reference. This is a subtle point often tested in advanced JavaScript interviews. Lexical scope means that scope is determined at Option A, runtime. Option B, compilation author time. Option C, execution time. Option D, deployment time. The correct answer is B. JavaScript uses lexical scoping, also called static scoping. This means that the scope of a variable is determined by its physical location within the source code during the compilation phase. It does not matter from where a function is called. What matters is where it was defined. This allows the developer to look at the code structure and determine the scope of any variable, without needing to track the execution flow. Which keyword allows you to redeclare the same variable multiple times in the same scope? Option A, let. Option B, const. Option C, var. Option D, none of the above. The correct answer is C. The var keyword allows for multiple declarations of the same variable name within the same scope, without throwing an error. The subsequent declarations are simply ignored or treated as assignments. In contrast, let and const will throw a syntax error if you attempt to redeclare a variable in the same scope. This is another reason why modern JavaScript prefers let and const to prevent accidental bugs. In a nested function, the inner function has access to variables of Option A, only itself. Option B, itself and its parent scope. Option C, only the global scope. Option D, only its parent scope. The correct answer is B. Due to the scope chain and lexical scoping, an inner function has access to its own variables, the variables of its parent function, and so on, all the way up to the global scope. This nested access is what makes closures possible. The inner function encloses the environment of its parent, maintaining a reference to those variables even if the parent function has finished executing. What happens if you assign a value to an undeclared variable in strict mode? Option A, it becomes a global variable. Option B, it throws a reference error. Option C, it is ignored. Option D, it throws a type error. The correct answer is B. In non-strict mode, assigning a value to an undeclared variable, e.g., x equals 10, without var, let, const, automatically creates a global variable. However, in strict mode, use strict. This action is prohibited and will throw a reference error. This is a safety feature to prevent accidental global variable creation and ensure that all variables are properly declared before use. Using let in a for loop header, for let I equals 0, creates a new I variable for Option A, the entire loop only. Option B, each iteration of the loop. Option C, the global scope. Option D, the function scope. The correct answer is B. When let is used in the initialization of a for loop, a new variable I is created and scoped to the loop block for every single iteration. This is particularly useful when dealing with asynchronous operations inside loops, like set timeout, as each closure will capture its own unique I value rather than a single shared I that keeps changing, which happens with var. Variables declared with var inside a function are Option A, accessible globally. Option B, accessible only within that function. Option C, accessible only within the block they are in. Option D, not hoisted. The correct answer is B. Var is function scoped. If you declare a var inside a function, it is local to that function and cannot be accessed from outside. However, Unlike let or const, it ignores block boundaries like if or while. This means a var declared inside an if block that is inside a function is still accessible anywhere within that entire function. In ES modules, variables declared at the top level are: Option A, global variables. Option B, scope to that module only. Option C, always constant. Option D, automatically exported. The correct answer is B. Unlike traditional script files where top-level variables become global, ES modules, files using import/export, have their own module scope. Variables declared at the top level of a module are local to that module and are not added to the global window or global object. This encourages encapsulation and prevents naming collisions between different modules. How are class declarations hoisted in JavaScript? Option A, fully hoisted like functions. Option B, hoisted but stay in TDZ like let const. Option C, not hoisted at all. Option D, only the name is hoisted but initialized as null. The correct answer is B. Class declarations are hoisted, but just like let and const, they remain uninitialized in the temporal dead zone, TDZ, until the execution reaches the line where the class is defined. If you try to instantiate a class before its declaration, e.g., new my class, you will receive a reference error. This is different from function declarations, which can be used before they appear in the code. Which of the following does not have its own this or arguments object? Option A, function declaration. Option B, function expression. Option C, arrow function. Option D, method in an object. The correct answer is C. Arrow functions do not have their own this arguments, super, or new target. Instead, they inherit these from the surrounding lexical scope, the parent scope. This makes arrow functions ideal for use cases like callbacks where you want to maintain the this context of the outer function without having to use bind this or a self equals this hack. What was the primary purpose of IIFEs before the introduction of block scope, let const? Option A, to speed up code execution. Option B, to create a private scope and avoid global variable pollution. Option C, to handle asynchronous data. Option D, to replace objects. The correct answer is B. Before ES6 introduced let and const for block scoping, developers used IIFEs, immediately invoked function expressions, to create a temporary scope. By wrapping code in a function and immediately executing it, all variables declared inside stayed local to that function, preventing them from leaking into and cluttering the global scope. This was the foundation of the module pattern in early JavaScript development. What is unique about the scope of the error variable in a catch error block? Option A, it is globally accessible. Option B, it is block scoped to the catch block. Option C, it is function scoped. Option D, it is not hoisted. The correct answer is B. Even before ES6 introduced block scoping, the error variable in a catch block was uniquely block scoped. It is only accessible within the catch block itself and is destroyed once the block finishes execution. This was one of the few instances of block scoping in early JavaScript versions. ES3, ES5. Although var declarations inside the catch block still followed function scoping rules. Which phase of the JavaScript engine involves setting up the scope and hoisting declarations? Option A. Execution phase. Option B. Creation phase. Option C. Garbage collection phase. Option D. Parsing phase. The correct answer is B. The JavaScript engine processes code in two main phases: the creation phase and the execution phase. During the creation phase, the engine scans the code, creates the global function objects, sets up the scope chain, and hoists variables and functions. It is only in the second phase, the execution phase, that the engine actually runs the code line by line and assigns values to variables. What happens if you try to access a variable that has never been declared or initialized anywhere? Option A. It returns undefined. Option B. It returns null. Option C. It throws a reference error. Option D. It returns nan. The correct answer is C. If the JavaScript engine searches the entire scope chain, from the current scope up to the global scope, and cannot find a declaration for a variable, it throws a reference error. This is different from a variable that is declared, e.g., with var, but not yet assigned, which would return undefined. Reference error. X is not defined is a clear signal that the identifier simply doesn't exist in the current scope chain. Which of the following is mandatory when declaring a const variable? Option A. Naming it in all caps. Option B. Initializing it with a value immediately. Option C. Declaring it at the top of the script. Option D. Using it only with primitive types. The correct answer is B. A const constant variable must be initialized with a value at the time of declaration. Writing const x without an assignment will result in a syntax error. This is because the value of a const cannot be changed via reassignment later. So it must have a value from the start. Note that const objects and arrays can still have their contents modified, but the variable itself cannot be pointed to a new object or array. Another name for lexical scoping is Option A. Dynamic scoping. Option B. Static scoping. Option C. Functional scoping. Option D. Block scoping. The correct answer is B. Static scoping, or lexical scoping, refers to the fact that variable visibility is determined by the source code structure. Since the structure doesn't change during execution, the scope is static. This is in contrast to dynamic scoping, used in some other languages, where the scope is determined by the call stack, the sequence of function calls that led to the current point of execution. Closures allow a function to remember its lexical scope. When is this scope created? Option A. When the function is called. Option B. When the function is defined. Option C. When the script is compiled. Option D. When the variable is assigned. The correct answer is B. A closure is created at the time a function is defined, not when it is executed. The function captures the references to variables in its surrounding lexical environment at the moment of its birth. This captured environment is then preserved and stays with the function wherever it goes. allowing it to access those outer variables even if it's executed in a completely different scope later on. Inside a function, which variables are hoisted to the top of that function's scope? Option A. Only var declarations. Option B. Var, let, and const declarations. Option C. Only function declarations. Option D. All declarations. Var, let, const, and functions. The correct answer is D. All declarations in JavaScript are hoisted to the top of their respective scopes. Function scope for var and function declarations. Block scope for let, const, and classes. The difference lies in their initialization. Var is initialized as undefined. Functions are fully initialized, and let const classes are left uninitialized in the TDZ. So, everything is hoisted, but they behave differently until the execution reaches their line. Does declaring a variable with let in the global scope add it to the window object in browsers? Option A. Yes. Option B. No. Option C. Only in strict mode. Option D. Only if initialized with a value. The correct answer is B. One significant difference between var and let const at the global level is that var declarations are added as properties to the global object, e.g., window in browsers. However, let and const declarations at the top level are not added to the global object. They exist in a global declarative scope but are not accessible via window variable name. This helps avoid accidentally overriding built-in window properties. If a variable is found in the local scope, does the engine continue searching the outer scopes? Option A. Yes. To check for duplicates. Option B. No. It stops at the first match. Option C. Yes. Only if it's a var declaration. Option D. Only if use strict is enabled. The correct answer is B. The JavaScript engine follows a shadowing principle during the scope chain search. It searches from the innermost scope outwards. As soon as it finds a variable with a matching name, it stops the search and uses that variable. It does not matter if another variable with the same name exists in an outer scope. It will be effectively ignored, shadowed, by the closer one. What is logged? Var x equals 1. Function x, console.log, type of x. Option A, function. Option B, number. Option C, undefined. Option D, reference error. The correct answer is B. During the hoisting phase, the function declaration x is hoisted first, then the var x declaration is processed. But since x already exists, it does nothing. However, during the asterisk execution phase, the line var x equals 1 acts as an assignment, changing the value of x from the function to the number 1. Therefore, at the time of the log, x is a number. Are variables inside an IIFE hoisted to the top of the script? Option A. Yes. They are global. Option B. No. They are hoisted to the top of the IIFE function itself. Option C. They are not hoisted at all. Option D. Only if they use var. The correct answer is B. Variables declared inside an IIFE, or any function, follow the standard hoisting rules within that function. They are hoisted to the top of the function's scope. not to the top of the global script. This is the entire point of using functions or IIFEs. To create a local scope and contain variables so they don't leak into the outer world. That concludes our deep dive into JavaScript scope and hoisting. How many did you get right? If you struggled with the TDZ or the scope chain, don't worry. These are some of the most challenging concepts for even experienced developers to master. If you found this video helpful, please give it a thumbs up and subscribe for more deep dive JavaScript content. If you have any questions about the explanations, drop a comment below and I'll do my best to help you out. For the full practice exam and more advanced JavaScript resources, check out the link in the description below.